Logs on one side, numbers on the other. First step for exponential is variables on one side, numbers on the other. Okay, so anything with an x usually goes to the left. Anything without an x is going to go to the right. What was step 2 with log equations? Okay, what we're going to do is put a log on each side, then we're going to expand. That's why we need to learn expanding. Step 3 before was? That steps out. We're going to simplify. And then the last step is solve as before. Log equations, which we did yesterday, are always non-calculator. These are 90% calculator questions. So they'll typically appear on different parts of the exam. So step number 1, and you're just watching, no copying. I'll do it again with you in a second. Anything with an x on one side, anything without an x on the other. So take a look. Do I need to move anything? No, x is already on the left. Step number 2, I'm going to do what's called taking a log of each side. So I can put any single base I want. I'm choosing base 10. Why? Because that's what the calculator knows. Now I need to expand using log laws. So the expansion log laws are exponents become coefficients, multiplying becomes, adding, division becomes, subtraction. So opposite than what we did yesterday. So I'm going to take the x and drop it in front. And that's why we need logs. There's no other way to get a variable out of an exponent. We can't x root it because that's not going to work. So logs are the only way to get an exponent down into the main equation. Don't copy yet. Just watch. Just watch. Okay? So I get x times log base 5 equals log 40. That's a multiplication. So how do I get rid of a multiplication by log 5? I divide by log 5. Can I cancel the logs? No, it'd be like canceling signs. It doesn't work that way. This now becomes a calculator question. So grab your calculators. Put log 40. Make sure you close off the bracket if you need to. Divide by 5. These are typically always decimal questions, and the default is 3 decimal places unless the question says otherwise. 2.292, that's correct rounding. There's a log equation. So somebody said yesterday, well, didn't we already do exponential equations? Yeah, we did, except they always had common base. If we go back to the beginning, can we change 5 and 40 and make a common base? That's why we have this log method, because we can't do it any other way. Okay, so I'll redo it with you. We'll do the method first, sorry. Step number 1. Move all variables to one side. Numbers to the other. Bless you. Step 2, we call it take a log of each side, or take the log of each side. Who invented logs? From Scotland. His name was Napier, John Napier. I asked the other class to guess the country. It went on for about 6 minutes. It was terrible. They were just all over the world. They had no idea geography. Yeah. Step 3, expand using log laws. That means exponents become coefficients. Multiplying becomes addition. Division becomes subtraction. For isolate x, and the last step, use your calculator. Do we need to check these? So are these special equations? Okay, so if we go back and we look, is there anything that I can't put in for x? So could x be positive? Yep. Could it be negative? Yep. Could it be a fraction? A decimal? Yep. So these are not special equations. It's only the log ones you have to check. These ones we never have to check. The answer is what it is. Okay, so let's go back to number 1 and do it together. Okay, step number 1, x is on one side, anything without an x to the other. We're done. Step number 2, take a log of each side. Again, you can put any base you want as long as it's the same on both sides. We're choosing base 10 so we can use our calculator. Expand means we're going to drop the exponent to be a coefficient. And again, just repeating, that's why we have logs. It's the only way to get a variable out of the exponent. Isolate x, so how do I get x by itself? Divide by log 5. If you think your brain is going to want to cancel those logs and make this 8, write yourself a note, never ever cancel logs here. They're never going to cancel out. Okay, so we can't just ignore them and say 40 divided by 5 is 8, so do not cancel logs. Last step is calculator. And we said it was 2.292. And again, usually 3 decimal places, but the exam will normally tell you how many.
Is that also to the 1,000?
That would be to the thousands, yes. Yes. Yes, to the thousands. Okay, well that's the most easiest exponential equation there is. So number 2 is kind of more typical when you've got x's on both sides and a bunch of stuff going on. So 4 to the x equals 3 to the 2x minus 1. Step 1. I actually don't want to. I want to leave it. Why do I want to leave it? I may have lied to you about step 1. Yeah, I want to leave it. Leave it. We'll come back to step 1, because this one I want to leave. I just don't know why yet. So I'm going to put a log on each side. Again, you can use any base you want. We're choosing base 10 because we want to use our calculators. And I'm just going to bracket that exponent because it's a binomial. So some people are going to see the next step better once they bracket it. So step 2, we need to expand. So this means that the 2 exponents are going to come down in front. So on the left, I'm going to have x log 4. And this is where we need to put the brackets, 2x minus 1 log 3. Okay, if you forget the brackets, then you won't have the right multiplication on the right-hand side. This is always the big question with logs is, can we multiply this through? So when do you multiply with a binomial? When do you not? When it's in front, it's good to go. When it's behind, no touchy. So can we multiply? Yes. So I'm going to multiply that log 3 through because the exponent law, or the log law, says that the exponent drops in front. Okay, so 2x times log 3, 2x log 3, minus 1 times log 3, minus log 3. Oh, this is where I want x's on one side. It's after step, I mixed up the steps. So let's switch 2 and 1, because we want to put logs, then we want the x's on one side. Oh, I knew it was in there somewhere. So just switch 1 and 2. So logs on each side, then once we do that. Okay, anything with an x on the left, anything without an x on the right. So x log 4 is going to stay. I want to bring 2x log 3 over, so I'm going to subtract it. And then on the right, I'm just leaving that negative log 3. Okay, so why did I move the 2x log 3 and I didn't move the minus 3 log, or log 3? doesn't have a variable. So anything with a variable to the left, anything without a variable to the right. Are we good on those steps now? Did I totally mess that up? Okay, next step is isolate the x. So I need to get that x by itself. What do I do? So if I divide by log 4, that's not going to fix this one. If I divide by 2 log 3, that's not going to do anything there. How do I isolate the x? I only have a denominator of 1, so that's not going to help. How can I isolate that x? Sorry? Because anything with an x I want on the left, anything without an x I want on the right. So these both have x's. Okay, so I'm stuck on isolating. How do I get an x by itself when there's 2 different terms? Say it louder. High five to you. This will always be a common factor question when you get to this step. Common factor. So we have an x in this term and we have an x in that term. So the only way to isolate it is just to factor it out front. So x log 4 divide by x log 4. And minus 2x log 3 divide by x. Perfect. And then negative log 3 on the right that I haven't touched yet. Now how do we isolate that x? Divide by? Sorry? Come down where? Why? I think you're thinking of the negative exponent law. So this is just over 1. So if you divide, you're just multiplying top by top, bottom by bottom. This now becomes a calculator question. The hardest part of this is the brackets. So because we have a fraction, we have to bracket the top and bracket the bottom. But because we have all these logs, what do we need to do at the end of them? You're going to bracket, we call it closing off. So you're going to need a bracket after the 3, a bracket after the 4, and a bracket after that 3. Okay, so if you want to clear, I'll read out what you have to punch in. So you're going to open a bracket, negative log 3, close, close. So the first one closes off the log, the second one closes off the top. Then divide, open bracket, log 4 close, minus 2 log 3, close, close. Hardest part of these is just getting it into the calculator properly. The calculator should have put one in here. Does it not? It should open one after the log, just like sine. Yeah, so it put it in for you. That's why you have to close it off. Do we have an offer? Does that sound confirmed? Rounded to 3 decimal places? Hardest part of these is getting the brackets in the calculator. Now you're going to see the next one's going to look almost exactly like this. The numbers are just going to change. So 2 to the 3x plus 1 equals 5x. Okay, step 1 is log both sides. Again, you can pick any base you want as long as it's the same on both sides. Why do we pick base 10? Calculator. Again, I like to bracket when the exponent is a binomial because sometimes that helps brains to see it better when you drop it in front. So step 2 is those log laws, says exponents become coefficients. Yep. So go right to with the in front, like this. You can. I'm going to caution you not to because it's going to get harder in a second. and you're going to have a harder time trying to do it all in one step. So if we just practice the same thing every time, it'll be easier once we get to the harder one. Can we distribute log 2? Why? Because it's in front, so we're going to multiply it through those two terms. 3x times log 2, don't overthink it, smush it together. 3x log 2. 1 times log 2. And right-hand side we haven't changed, x log 5. Now is the step we want x's on one side, anything without an x to the other side. So what do we need to move? X log 5 needs to come to the left, and log 2 needs to go to the right, so let's do those in one step. So 3x log 2 is going to stay. Then we're going to have minus x log 2, or 5, I mean. And on the right, almost, negative log 2. Why is it negative? Because it flipped. X over here, what's the only way to isolate it? So 3 log 2 minus log 5 equals minus log 2. How do we isolate x? Divide by all that. So I get minus log 2 divided by 3 log 2 minus log 5. Ooh, can we cancel the log 2's? Why? That's a puppy killer right there. We can't cancel half a binomial. So if you think your brain is going to want to do that, make a note. You're never going to cancel anything here. Ever, never, never. No canceling. It's all going to go right into the calculator. Okay, just a reminder, you have to open the top. You have to open and close the bottom. You also have to close after every log. A little bit louder, sorry. Confirm? Do you see how these questions are very, very similar to each other? Are we good? Waiting. Okay, 4, let's play back and forth. You do a step, then I'll do the step. Then you do a step, then I'll do the step. Okay, so you do the first step, and then we'll check second, and we'll check. I feel like you just want to do the whole thing yourself. That's awesome. I'll just work behind you so you can check if you need to. Steph. So I just distributed. Again, it's usually this step. We see a lot of canceling on the exam. Okay? Don't let your brain let you cancel. This is puppy killing. Never cancel in this step. Just throw it all into the calc. Anybody have an offer? 9.166. Don't you feel like you're doing real math? Look at this. You show that to an essentials kids, they're going to cry. Now I'm curious in chem, where do logs come up? Because I know you use them, I just don't know for what. And do you know why? Interesting. So it's got to be something with an exponential function. I'm going to research that. We'll talk about it tomorrow. Log times the concentration. Yeah, it's got to be that the variable's in the exponent, it's come down. That's interesting. My job is just to show you the what. Okay, 5 is a very typical exam question. It's probably one of the poorest on questions on the exam. The poorest, like one of the worst questions. When we get together, so all the math teachers in the division get together for about 12 hours and we mark all your exams, and so we are given 3 to 4 questions and we mark the same questions on everybody's paper. So I'll mark 3 on yours and I'll mark 3 on Westwood's and 3 on JT's. And nobody wants the log question, nobody wants the identity because they take forever. So every year we're like, yeah, no identity. So I'm going to show you the wrong way to do it, and I encourage you to put it in your notes because it's what we see over and over and over, but I know some people don't like wrong stuff in their notes, so up to you, but I really encourage you for this one. So I'm going to start with a no. This is what you can't do with this one. You can't say this is 6 to the x and 5 to the x minus 1. And it's what your brain is going to want to do. Why is that mathematically wrong? Because of the exponent. So BEDMAS says we'd have to do what first? The exponent. We can't just multiply the bases like that. Okay? And again, in exam panic, this is usually one of the last questions. You're tired, it's 2.5 hours. You have to pee, you really just want to get out of here. That's what your brain's going to want to do. If you do that, you're getting about half the marks for the question because you're going to get a mark off for doing that multiplication. And then if you make the question simpler for yourself, you get an extra mark off. So if you take a really hard question and end up making it simple because of your mistake, that's 2 points off. This, when we get to the step when we're expanding, is going to be product law. So I want to put that in the question too. Anytime you see a multiplication in the question, that's going to end up being product law. If it was an easy case of just making that 6 to the x, we wouldn't have given you the question like this. We would have given it to you as 6 to the x. So if something seems unsimplified like that, there's a reason that it is. Okay, so no 6 to the x. What do? We follow the exact same steps. Step 1 is log of both sides. So I'm going to log 2 times 3x, and I'm going to log 5 times x minus 1. Now just for a second, I'm going to cover the right-hand side, and I just want you to look at this little bit of the question. We did these 3 classes ago when we looked at expanding using exponent laws. And we said the first thing you do is split it up, then you drop exponents. And by splitting it up, if you're multiplying, you add. If you are dividing, you subtract. So the first thing is to split it up. So I'm going to break it apart right between that 2 and that 3x, because that's where I'm going to split. So I'm going to have log 2, and I'm going to have a log of 3x. And because I was multiplying, it becomes addition. Okay, so you're expanding, you're making it bigger, you're splitting it up. Now I'm going to look at this x on the 3, and what am I going to do with it? Just drop it in front, so I'm going to have log 2 plus x log 3. So sometimes, especially if you're visual, it's good to hide parts of the equation, because if I just gave you this, you probably wouldn't put 6x. But the minute we put it into an equation, your brain's like, bah, too much stuff, need to simplify. Okay, what would I do on the other side? So again, let's just look at this. Do I need to split anything apart? Why not? Because it just have one base. So if you need the brackets, put the brackets. I'm going to jump right to that exponent law that says I drop it in front. And there's the first step, simplify using log laws. Ooh, not quite. I'm going to multiply this through. There is a log question on every single provincial exam I have ever seen, although I won't see yours till you see it. I'm going to guess there's going to be a log equation. It's either going to look like number 5 or like the one we're going to do in number 6. Okay, it's always one of these ones you have to split apart first. At this point, everything's just the same. So what are the normal steps that we do now when we got stuff kind of hanging out all over the sides? X is onto one side, non-X is onto the other. Factor out X. If you can do the factoring and the division in one step, feel free. So if your brain can go right to X equals negative log 5, negative log 2, divide by log 3 minus log 5. Okay, you can skip that step. If your brain's like, whoa, then do the factoring and then do the division. Can I cancel these nice negative log 5s? They look so pretty there. There's one on the top, there's one on the bottom. Why can't I cancel? That's killing puppies. So again, no canceling ever going to happen here. Not in this step. And because you're throwing it all into your calculator, even if you could cancel, the calculator will do it all for you. So there's no reason you'd have to do it yourself, even if we could at some point. Offer? That sounded confirmed from way back there. 4.508? Not confirmed? Confirmed? Now, you're on the exam, and rarely there's a shortage for time on the exam, so you'll probably be done ahead of time. And you're like, oof, I'm not sure about that log question. How could you check this on the exam? Remember, you can check any equation at any time. What would you do? Go back to the beginning, put it in, and if you've done this mistake, it won't equal. So that's usually an indication, maybe I've done something wrong in there. Questions so far? You go back to the original and substitute in your x, and you're trying to see if the two sides are equal. Number 6 is as hard as they're going to get. What am I going to tell you that you can't do here? You can't divide. You can't take this and make it 6 to the anything.
Last name, Aguilera through to Connolly, Crochet. If you could please head to room 2E5. Thank you.
Okay, so you can't make it 6 to whatever your brain thinks it's going to equal. That's a no. The minute you see a division, for the love of God. The minute you see a division, what's the law called? Quotient law. And I'm going to write the same thing on the question to make sure you see it. Quotient law. Okay, log each side. So I'm going to keep all this crap right now that's on the left. 12 to the x, divide 2 to the 5x minus 3. And then just a little log 7 on the other side. On the left, I need to split this up. When we see a division, we know it equals subtraction. So I'm splitting the top and the bottom. So I'm going to have log 12 to the x minus log 2 to the... Another really, really, really common mistake that we see over and over and over is people will forget to log the right-hand side. They'll be so involved with this nasty fraction, and I know I need to split it, and I got these x's all over, they'll completely forget they'll make this equal to 7. Okay, so make sure when you log on the left, you're logging on the right. And again, if you check it at the end and it doesn't work, it's probably that you forgot a log or that you split this incorrectly. Okay, what do exponents do? They do move. Here's another really, really, really common mistake. I didn't bracket. So mathematically, why is that wrong? Because this I'm only multiplying log 2 by 3, and what do I need to multiply it by? So if you drop the brackets, but you continue like it is a multiplication, so you've dropped them, but in your head you know they're there, that's a half mark off. If you drop them and then you ignore that they're there, that's a full mark off. So we do what's called an arithmetic error versus a conceptual error. Arithmetic error is you just forgot to write brackets, or you multiplied 2 numbers wrong, or you missed a negative. If it's a conceptual error, so you don't actually understand there's brackets, that's a full mark off. And again, close to the exam, I'll give you the whole list of everything we take marks off for. This is why these are so hard to mark, because there's so many common mistakes. So you'll have one student that divides by the 6th and then does something from there. You'll have someone else that forgets the log. You'll have someone else that forgets the brackets. Okay, that's why we hate marking these. Can I distribute? So far, what has the answer always been to that question? Yes. What about yesterday? It was a no. So these will always have distribution to them. The other ones, not so much. Where did the plus sign come from? So we've got a negative, and we've got this log 2 in the back. So if your brain was like, whoa, what happened there? You can always write the log 2 in the front, because that's really how we're used to seeing a distribution. So if your brain sees better that, oh, it's negative log 2 times negative 3, then just write it in front. Okay, but this would become a plus. Again, if you go to check it at the end and it doesn't work out, it's got to be something in there. Check your logs, check your pluses, check your expansion, blah. And then the other side, whew, just log 7. It's like a little sigh of relief when we get to this step, because everything's always the same after here. So x is on one side, numbers on the other. What will I have on the right-hand side? Any of you that have younger siblings, just call them over when you're doing this homework. They're going to think you're a genius. Cancel the log 2's, but they're right on top of each other. And it really looks like they can cancel. And it's going to make the question easier. Yeah. No canceling ever, ever. And though I've said that now 6 times, someone's going to want to cancel in this step. Offer? No offer? 136. Oh, that got confirmed. Questions? This is as hard as it's going to get. This is the hardest thing in the unit. So I just want you to make a note at the bottom. Because sometimes these exam people try to trick you. And sometimes they'll put the question like this on the non-calculator section. So look at all the examples we've done so far, all 6 of them. Is there any that we did not use a calculator? No. So if an exponential equation appears on the non-calc section, what that tells you is a common base question. And because now you know logs, your brain will forget about common base and it will just want to put logs on each side. And you're going to get all the way down to here and you're like, I don't have a calculator. So if you see it on the non-calc section, it means there's a second method, which was common base, that we first used. So note, if an exponential equation is on the non-calc section, look for common base first. If an exponential equation is on the non-calc section, look for common base first.